Hey folks, Mrs. White here. I just wanted to provide you with an opportunity for another little quick review before you take your test today. Um, I've emailed at this point everyone who I've gotten a hold of their parents. They have a copy of your test. It should be completed before Wednesday, so you don't have to necessarily do it today. If you anticipate needing a little bit extra time, then I want you to try to maybe do one sitting with one side and then another sitting with the other side if you think that might be something you're interested in. I think it's pretty reasonable. So give yourself an opportunity to study a little bit before and then get going. So, quick review. You could see something like a mono times a mono. So, to do this, we're going to multiply like terms. So, negative 2 times 4 is negative 8. B to the third times b squared means we add. When we multiply bases, we add our powers. So this is going to become b to the fifth. And then c to the first times c squared, I add those powers, I get c to the third. Okay, so here's my answer for that one. Mono times a mono should equal a mono. Next, we could have a monomial divided by another monomial, and this is just like simplifying a fraction. So negative 7 divided by 21, well, a negative divided by a positive is a negative, and 7 goes into 21 3 times, so I could rewrite this as 1/3. Then my x's, our exponent property here is top minus bottom power, so 5 minus 7 is going to give me an x to the negative 2. I'm going to look at my y's. They're going to cancel because they have the same exponent. Z to the fourth over z squared, so I'm going to do 4 minus 2 is 2, so I'm going to have z squared here. Now I'm not entirely done. I'm still going to have a negative on the outside. I don't need a 1 in the numerator. I'm going to take this because it has a negative power and I'm going to put it below with the 3, which is already there, and make my exponent positive. And then I'm going to keep a z squared up top. Okay, there's my answer for this one. I'm also going to potentially have a poly times a poly. I could have a mono times a poly. Either way, we're going to do distributive property here, and we're going to have to do double distribution. Okay, so this is going to go there, there, and there, and then I'm going to have to distribute the b across also. So I'm going to go very quick. A to the first times a to the third is a to the fourth. A times negative 3ab is going to be negative 3a squared b. Then I'm going to have a times negative b squared, so negative ab squared. I'm going to then distribute this b across here, and way over here. So I'm going to have positive b times a to the third, so it's going to be a positive a to the third times b. Then I'm going to have a b times negative 3ab, so it's going to be negative 3a b squared. And then lastly, b times negative b squared is going to become a negative b to the third. Now, if I were to go through and simplify this just a little bit further, okay, I'm going to just combine like terms. I should go from highest to lowest power. So I'm going to start with my a to the fourth. Then I have minus b to the third. So I could put that. I could also put plus a to the third b. It doesn't matter. Okay, you're going to have to stick with me. This pen's being a little funky. I think it needs a new battery. I'll put my b to the third power next. So I've done that. I've done that. I've done that. Now at this point I need to slow down a little bit. Here I have an a squared with a b. Here I have an a with a b squared. Here I have an a with a b squared. So I can put this item and this item together, but not with this one. Okay, so maybe I'll put this one first. Negative 3ab. And then I have negative 1ab squared and negative 3ab squared. So together I have negative 4ab squared. And this is my answer to that multiplication problem. Coming over here, this is both an addition problem and a multiplication problem. So I have a mono times a poly, so I'm going to distribute it in first. I'm going to distribute a positive 2c here and here also. And then I'm just going to combine like terms. So again, I'm going to go very quick just because we're reviewing. It should be 10c to the third minus 15c squared. And then 5 times 4 is positive 20c. Okay, and that's a positive. Then I'm going to take my positive 2c and my 7c and multiply those. So that's positive 14c squared. And then positive 2 times negative 8 is negative 16c. So looking here again, highest to lowest powers, I start out with a 10c to the third. Then I have a c squared and another c squared, so negative 15 and positive 14 is negative 1 c squared, or just negative c squared. Then I have 20 and a minus 16, which is going to give me a positive 4c. And at this point, that's all my pieces and parts, as simplified as it can be. The next series of problems that you'll see are going to be division problems. Here we have a poly, it's 2 pieces divided by a mono, and then a poly, and then this means divide, right? Because this would put this in the denominator. So it's a poly divided by a poly. So in this instance, we're going to distribute this denominator here and here. So I'm going to do kind of 24 divided by 4, which gives me a 6. And then m to the first over m squared is going to be m to the negative 1. And then n to the 6th over n to the 3rd is going to give me 6 minus 3, which is 3. Now this piece should be simplified, but I'm going to hold off on doing that till my last step. Now I'm going to send the same denominator under here. So I have 40 divided by 4, which is 10. M squared over m squared, which will cancel, and n to the 3rd over n to the 3rd, which will cancel. So the only thing I need to simplify here is I have a negative exponent. I cannot combine like terms, okay? And I'm not going to do negative 10 times 6 because this is a minus sign, right? This was a poly with a minus. So I end up with 6n to the 3rd over m, right? Because I just changed its location, minus 10. Now I can't do that same thing here, even though this problem could be rewritten as over 5a minus 6. Okay, that's all that negative 1 means, is put that in the denominator. This is a poly divided by a poly. I could choose to do synthetic division or long division. If you have a coefficient here that isn't 1, you should definitely do long division. So I'm going to set that up and we can review that quickly. In there, I'm going to make sure I have all my powers 2, 1, and none, so I don't need any fillers. So I'm going to put 30a squared minus 11a plus 15. So I'm going to look here and here. 5 times 6 will give me the 30, and a times a will give me my a squared. I'm going to distribute it across. I get 30a squared. 6 times negative 6 is negative 36a. I'm going to intentionally change my signs, right, folks? Make sure you're subtracting, and when you subtract, you distribute that negative to both parts. So those cancel. Negative 11 plus 36a is going to give me 25a. And I'm going to drop down my 15. At this point now, I'm going to continue. I'm going to see how can I make 5a look like 25a. And I do that by timesing it by just a positive 5. Okay, it already has a to the first. This already has a to the first. So I'm going to distribute this to both pieces. 25a, and then 5 times negative 6 is negative 30. I'm going to intentionally change both signs, okay, by distributing a negative. And I end up with 15 plus 30 is 45. Now, there's nothing else to bring down, so this is my remainder. It's a positive 45, so I put plus and then 45 over my divisor, and my divisor is 5a minus 6. This is my answer. If there's no remainder, you would just have 6a plus 5. Let's move forward and take a look at some of the graphing stuff. So you're going to be asked to describe end behavior, determine if we're dealing with an odd function or an even function, and then state the amount of real zeros, okay? So zeros are how many times it hits the x-axis. So we would say that this has 2 zeros. If we're determining if something is odd or even, you count up how many zeros there are, and if that number's even, it's an even function. If that number's odd, it's an odd function. So this would clearly be an even function. If we look here, 1, 2, 3, 4, 5, this has 5 zeros. 5 is an odd number, so this is an odd function, okay? There are a couple other attributes, like with an odd function, the end behavior is different directions, and with an even, it's the same. You could look at that also, okay? So if we actually talk about writing the actual end behavior, though, it always starts with as x approaches positive infinity and as x approaches negative infinity. So as x goes out to positive infinity, our line's going down here. So we would say that our y is approaching negative infinity. As x approaches negative infinity, which means x-axis headed out towards negative infinity, it's still going down, so y would also approach negative. Okay? Because they both go down, that tells us that it's an even function. But as far as describing these three things, this is how we do it, okay? End behavior, amount of zeros, and even or odd. Here, we always start our end behavior with as x approaches infinity and as x approaches negative infinity. Okay, we're going to look at what happens to our y's. As x comes out to positive infinity, our line's going down, so our y is going to negative infinity. As x goes out to negative infinity to the left, our line's going up, right? So y is approaching positive infinity. The only other thing you might see on your assessment is going to be what are the relative maximums or minimums. And so a relative max or min is going to happen at a peak or a valley. Okay, so you could have several of each. So this one would have a relative maximum here and here, a relative minimum here and here. This one would have a relative maximum here, and a relative minimum here. If you're asked to name where that is, you're going to look at where it is and you're just going to approximate it. Okay, so I could say this one would probably be happening, and you always approximate it with the x's. I'd probably say between, based on my graph, x equals 7 and 8. Okay. If it looks like it's happening between the two, if you think that it hit the low point exactly at 8, you would say at x equals 8. That's fine. Okay, and that would be a relative minimum. If they ask you where the zeros are located, and again, zeros are x-intercepts, so are there any zeros on this graph? No. But let's say this was labeled, okay, 1, 2, 3, okay, and our 0 happens between maybe -2 and -1, because these would be negatives to the left, right? Okay, I would say between x equals -2 and x equals -1, or this one I could say between x equals -3 and x equals -2. Okay, now if you're looking at a table, you're going to be able to tell where your zeros are, where it goes from negative to positive or positive to negative. Okay, and we talked about that in class. That was not a huge part of the review that I conducted in the previous video, but hopefully you did take a look at those notes and at the key that Ms. Boyce made. The last thing that's going to be on your test is going to be solving polynomials being given one factor. Okay, so we know this is a factor. They're telling us that, but in order to continue with this problem, we have to divide it out. We do not divide by -4. We're going to put a +4 in our box, and we're going to use synthetic division. I'm going to put all of my coefficients across the top here. I need to make sure all my powers are already identified in my function. So 3, 2, 1, and none, I'm good to go. So my coefficient here is 1, my coefficient here is 1, then -14, and then -24. Okay. I start by dropping my first digit. 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. -14 and 20 is 6. 4 and 6 is 24. My remainder is 0. I knew my remainder was going to be 0 because if it's a factor, there's nothing left over. It divides nicely. Because this is a power of 3 to start with, that means here I'm going to have an x squared, and then I'm going to have a plus 5x, and then a plus 6. So to get my remaining factors, folks, I need to factor this, okay? So to the side, I'm going to make my little factor chart. What multiplies to be my a times my c, so 1 times 6. What multiplies to be 6 and adds to be my b, which is 5, okay? So what multiplies to 6 and adds to 5, that's a nice one. It's 2 and 3. So I'm going to rewrite this as 4 pieces now. So I'll have an x squared. I will have a plus 2x. I will have a plus 3x, I will have a plus, keep my c original, 6. I'm going to group them. And I'm going a little quick here because I already went over this previously. This is just a little quick review. I can divide an x out of both of these, and I'm left with x plus 2. Okay. Over here, I can divide each of these by 3, and that's it. So I'm going to have a 3 on the outside, and I'm left with x plus 2. I know that this worked because these two parentheses match. That means my remaining factors are x plus 3 and x plus 2, okay? And that's what I would write on my line on my test. You're going to have, I think, 3 problems on there that are going to be like this. The one thing we didn't count or review right now is all those different factoring strategies. Hopefully you chose to add those to your one sheet of notes you're allowed on your test, okay? So at this point, I do whatever review you feel like you need to do, and then touch base with your parent and get started on that test. What I would like to see is it handed into me attached to this assignment, okay? So this, even though it's a review video, I want you to send it in as this assignment, and I will grade it. So you're going to take a handful of pictures and attach them all to this, okay? Do not just send me pictures of the test. I want to make sure you have work that you're also sending for partial credit, right? It's important that you earn that if you've earned that, for sure, okay? If you have any questions, you can reach me via email, also on the classroom. But if you have questions about specific problems on the test, please do not post those to the classroom. They're not for everybody, they're really for me, okay? Good luck, folks. Again, reach out if you need to, and I'm hoping to get some rockin' tests back from you. Thanks again. Bye.